Hello students, welcome to Vipin Sharma Physics channel. Well students, in the wave optics, I have been explaining you the theory of light. I've told you earlier Newton's corpuscular theory of light. Now, I'm going to just share concepts of wave theory of light. So wave theory of light. What if the student asked me one question? What is the purpose of giving theory of lights, various theories of lights? Well, students, to understand physics and to grip the concept, we have different theories given by the scientists, and those scientists were very much convinced that they are the best and they are the right. But with time to time, scientist comes after scientist, and they are rebellion by nature. They are not yes men. Scientists are rebellion by nature. They are not yes men. So, in the wave theory of light, uh, like every scientist is going to, I mean, put forward his own concept and uh, trying to prove that he is or she is doing something more better than the earlier one. So in that scenario, research is there, R&D is there, right? So wave theory is one of the outcome of the scientists. When we talk about light can be thought of a wave. We immediately think of disturbance. You know, disturbance travels in all direction, and you see, when we talk about the wave, we think of the ripples. Ripples. uh, Ripples, like this kind of, I can tell you a very simple concept of ripple. Take uh, take a pan, and in that pan you add water and place it on a table, and then put your mobile on the vibration, place the mobile below the pan, and when vibrations takes place, then there are this kind of, as you see my hand, this kind of movements in the water, that is called ripple. Means like kind of crest troughs. Like, I'm not exactly crest and trough. The particles travels back and forth. The particle travels back and forth. Now you'll put a question, the particle travels back and forth, like kind of a simple harmonic motion we have studied in 10 plus 1. But in case of light, the particle is not traveling back and forth. In case of light, there are electric and magnetic field vectors. And according to wave theory, light, is an electromagnetic wave. You know, in electromagnetic wave, the particles, in mechanical waves, the particles move back and forth. But in electromagnetic wave, there are oscillations of electric and magnetic field. There are oscillations of electric and magnetic field. Well, students, when you talk about the electric and magnetic field oscillations periodically, periodically means uh, there there is one is called an electric vector and other is called a magnetic vector, and when you have the cross product of the two vectors E cross B and you get a pointing vector, so E cross B, the pointing vector is coming out of the plane of the board, and the light propagates in the direction of the pointing vector, but it propagates in all directions. It propagates in all directions. When it propagates in all directions, then it is wisely said as the speed of light. This theory is useful, in explaining the concepts of interference, then comes diffraction, then comes polarization. Interference, diffraction, polarization. Is it clear? I'll get this side, right? Interference, diffraction, polarization. The phenomenon of mixing the two waves, light waves coming from the coherent sources called interference, and the phenomenon of bending of light when it is negotiating the sharp corner, and that size is comparable with the wavelength of the light is called polarization, diffraction. The phenomenon of bending of waves around the sharpest corner is called diffraction. The polarization is when we rotate the plane of the vibration of the light, left labio, right dextro. That is how we can explain these three concepts. Well, one of the student is putting a question, sir, wave theory of light explain all the concepts? No. We use wave theory to explain the wave phenomena. We use wave theory to explain wave phenomena. You will put a question, sir, what is the meaning of other phenomena? Why wave phenomena? Why not other phenomena? Well, that is really a important thing and a point which we'll be discussing in quantum theory, and then we'll come to conclusion what light is. But should I say one thing? We don't know what is light is. Yet we don't know. Anyway, students, simple to the point, I've explained you what is wave theory of light. Thank you. I will not repeat it because since it is on the YouTube, you can rewind and play it. That's it. Thank you. Thank you very much. See you in the next lecture, that is called quantum theory of light. Correct. Thank you. Bye bye.